In this lecture, we'll talk about another collection type called sets, and then take a look at differences between lists and sets. By definition, set is an unordered collection of elements that do not contain any duplicates. Again, let me break this down. A collection of elements means a group of things, same as a list. Unordered collection means we can't say where each of the elements live. They're just in there somewhere. Not in a particular order though. A collection of elements that doesn't contain duplicates, which means each value can be added to the set just once. So while a list is very orderly and could possibly contain two or more identical items, a set doesn't have any order, and each element can exist only once in the collection. If you think of it in the fruit platter perspective, it cannot have more than one apple or an orange. No duplicates. I also want to make a small note here. You can try adding duplicate items to a set, but it'll just ignore them. We can use our developer console to write code. Let me open the Execute Anonymous window. The syntax to define a set looks like this. Set data type set name equals new set data type. If we were to initialize the list with couple of values, it would look something like this. Set data type set name equals new set data type and values. The syntax looks almost identical to the list except for the keyword set. Let's define a set called platter with 3 existing fruits. Since we would be putting in names of fruit, the data type is string, and we are initializing the list with 3 values: apple, orange, and a banana. Since we have a set now, there are a couple of methods that let us work with sets. For example, to add an element to a set, I could use the add method. This would add a peer to the set. If I do this again, then do you think another peer would be added to my platter? You would have to wait to know the answer. Let's use a system.debug to capture the platter size after the code runs. Number of elements plus platter size. Let's run this code and take a look at the log. The number of elements in the platter size is 4 and not 5, because sets cannot contain duplicates. Though we try to add a duplicate, the system would just ignore it. So, no duplicates in sets. If we wanted to remove an element, we could use the remove method. Platter.remove banana. We just removed an element from the set. Let me write a debug statement to check if the set actually contains banana. This contains method would return true if the set contains the element banana. Using the simple loop and a debug statement, I can print out all the elements in the set. For string p, platter, system.debug, element plus p. Don't worry about the for loop syntax for now. I'll talk about them in detail in later lectures. But what the code does is, it loops through all the elements in the platter and prints them out. We can even clone our platter using a clone method. Here, I'm creating a clone of platter called bowl equals platter.clone. Let me also display all the contents of the bowl using a debug statement. System.debug contents of bowl plus bowl. This would remove all the elements in the platter list. I can also validate if the platter is empty by using the isEmpty method. System.debug bowl.isEmpty. Let's run the code. We have debug statements all over, which makes it easy to understand what's going on. Let's take a look at the log. We started with 3 elements. We tried to add 2 pairs. Since sets don't accept duplicates, only one pair was added. So the number of elements are 4. Then we try to remove an element called banana from the set. So the set no longer contains banana. Using a loop, we try to print out all the other elements in the set. Then we cloned the platter set and called it bowl. Here we are trying to display all its contents. Then we emptied the bowl using the clear method. And finally, we are checking to see if the set is actually empty using the isEmpty method, and it returned true. We do have more set methods available. You can find them in the cheat sheet. So when do we use a list versus set? It's really a good question. Lists are used a lot because they are very flexible. Lists can contain duplicate items. For example, you can have more than one orange in your platter, and they can be used when you want to order other things. Perhaps we are extremely tidy and want to display our fruit in a particular order. But sets have their value too. When deciding between using a list or a set, just ask yourself these two questions. Is order important? Do I want to allow duplicates? If the answer is yes to either one of these questions, then use a list. Otherwise, use a set. Summing up, set is a collection of unordered elements and cannot have duplicates. Sets have methods to work with. We can add, remove, clone, calculate the size, check to see if the set contains an element, clear off the set, and check to see if the list is empty. There are a few more things that we can do with sets that I haven't covered here. For more information, check out the cheat sheet that shows you different things you can do with sets. If the order is important, or if you want to allow duplicates, you might want to use a list. Otherwise, use a set. In the next lecture, I'll talk about another interesting type of collection called maps.